Good morning, students. In this session, we are going to see what is a producer-consumer problem in the process management. And myself, Dr. Shirisha, Associate Professor from Department of CSE, MLR Institute of Technology. So, what is producer-consumer problem? If you have a process where it has to produce some items, and also whenever it is a case where you take a memory. Okay, if the memory is free, there is a free space. Therefore, the producer, what it can do is the producer can always produce an item. So, if a producer has 10 or 5 processes that has to produce, then this process has been produced here. Okay, P4, P5, say P6, 6 process. Since it is empty, and then it can produce. Now it is full. All are filled with 6 process. Now it is full. Now producer can produce item P7? No. P7 cannot be produced by the producer. Then what it has to do? Consumer. The consumer on the other side has to consume the process. It can consume until the buffer is full. And it will remove the process. I can consume the process until the buffer gets empty. Okay, it has consumed P1, P2, P3, P4, P5. Okay, and also P6. All these are consumed. Now the buffer is empty. Buffer is empty. Now consumer can consume the items now? No, because this is empty. So, when the buffer is empty, the consumer cannot consume the item. When the buffer is full, the producer cannot produce the items. So, we'll see what is this producer consumer and how it can be implemented using the code. So, parallel diagram for cooperating process. Cooperating process are nothing but where producer process produces information that is consumed by the consumer process. It's a cooperating process, because if consumer is not consuming at all, and then there is a memory full of memory where producer has produced all the items in the memory. Now, until and unless the consumer consumes, the producer cannot produce an item. So, that is the reason we are calling this as a cooperating process. And in the same way, vice versa. The consumer has consumed all the items until and unless now the producer has to produce into the buffer, the consumer cannot consume the item. In such a way, both the process has to be the cooperative process. That's the meaning of the cooperation. Okay. Unbounded buffer and bounded buffer. What is the difference? Unbounded places no practical limit on the size of the buffer. Unbounded means no practical limit. Bounded means there is a fixed buffer size. Bounded means limit. Okay, limited. Okay, there is a bounded buffer. So, we'll see what is the consumer problem. So, there's a something called shared data that has to be shared among both the producer and consumer. Since that information is known by the producer and also the consumer, the data can be called as a shared data. So, here we see we have given the buffer size as 10. So, what is this? Is it bounded or unbounded? It is bounded. So, it is bounded because it is bounded to only 10. You cannot include one more character and make the size as 11. No, because the size is fixed. We are using the fixed size buffer here, and the buffer size is a variable which has been taken, and we are defining using the hash define. And type def is type def, and we are giving the structure for here. This is a structure where you can give the item and produce the items into the buffer. And this structured item is carrying all the items that the producer is producing and the consumer is consuming. That is item. So, item buffer size is what? It is 10. So, item has a buffer with the size 10. Now, there are two different variables that we need. One is to in. When you have a memory, then one operation, in operation will perform a process to produce. In will produce. In the same way, out will consume. Okay, whenever you are you wanted to make a process into the memory, that is swap in or swap out. When it is not, when it doesn't require that process into the memory, if you wanted to remove that, then we have to consume it. So solution is correct, but can only use the buffer size minus one element. So here, whatever the element size we have, buffer size 10 means, so 0 to 9 elements we can take. Okay, so here item next produced while true. If there are some items to produce, if there are some items in the ready queue, then while of true, yes, some items are there. Then what you have to do? Produce an item into the buffer. Now you are producing what? P1 here. Because there are some items. Here I have what? Say P1, P2, P3. Now this is true. So while of true, this is true because you have some process that are there to enter into the critical section or enter into the buffer. Now produce an item into the produce. So you are producing the first item P1. Then what happens? You have to check this condition. So what is my size? Say 3. So in plus 1 percentile the buffer size. In plus 1 percentile the buffer size equals to out. So in is initially 0. Right? 0 plus 1 percentile buffer size, say we have taken 3, that is equals to 0. So 1 percentile 3 is 0. So whenever this condition is true, then you are producing the item. Otherwise, it will go to the next produced item, put it in the buffer in. Okay, go to the next item. So this condition is true, right? So it is going to the next process P2. Now P2 is also entering into the critical section. Again, now what happens? In equals to in plus 1 percentile buffer size. Now what is here? Now what is in? In is equals to, in is 0 plus 1 percentile 3. Okay, 1 percentile 3, 0. Okay, now in that way, whenever it is going for the next process, next produced means it is going to the next produced item. Therefore, initially it is 0, in is 0, 0 plus 1 we have taken, and initially here it is the buffer size in is equals to 0. Okay, so in that way it is producing the item. So the while of true, whenever the condition is true, the process will repeat until all the items in the process or in the ready queue are produced into the queue. This is how the producer can produce an item. The process can consume. So this is next consumed, means if you have any process, if the buffer is empty, is there any process to consume? Then while of true will become false. Whenever the condition is false, it comes out of the loop. When the condition becomes true, whenever you have the next consumed process. So if you have some process Pi, Pj, two processes are there. Whenever you have such process, then it will check whether is in is equals to out. Okay, means if in is equals to out, your condition is here. Okay, you are producing, you have to produce the item here, then only the consumer can consume the item from here. So buffer of out, you are sending it to the next consumed, means buffer of out means initially say 0. So buffer of 0, you have Pi. So Pi you are consuming. Next, what is the process that you have to consume? Here. So next, what is the process? B of 1, then that will be Pj. So like that it will repeat. Okay, so 0 plus 1 percentile buffer. So it goes to that particular place, that particular location, and consume the item in the next consumed process. Now what is happening here? Whenever there are no process into the queue, now what is your in? You cannot go here because there are no items in the next consume. This is 0. Then while of true will not become true. It is false because there are no items in the process buffer to consume. Therefore, it will not go into the critical section. So when this will get executed, there are some items in the queue. When there are some items in the queue. So whenever you have items here, so while condition will get executed. So there are some items in the queue, this condition became true. So enters the critical section. Now here while of in is equals to out. So what is in initially in and out equals to 0. 0 equals to 0. Yes, condition is true. Now buffer of out, buffer of 0. What is there in the buffer of 0? That means in the first location. So that buffer will be consumed. So this will get consumed here. Okay, then 0 plus 1. 0 plus 1 means again this will become 1. 0 plus 1 is 1. 1 percentile buffer size. Okay, so buffer size say 3. Again 1 percentile 3. 1 percentile 3. Maybe this can be happen. Okay. So therefore the item at this position can be consumed. So in that way you will loop the process and you will increment, then 2 percentile 3 in the next case. Then what happens? 2 percentile 3 means it will go to the first. So it will go to the first position and then it will again consume this process. In that way all the process in the buffer will get consumed, and once the consumer process has consumed all the process, this is also consumed. Next this will be consumed. Now this will become consumed. Now if all the 3 are consumed, then what happens? The buffer will become empty. Now do you have any process to produce here, consume here? No. Then when there are no process to consume, again you come back here. Now your buffer is again empty. Now what you can do? You will see whether there are any items in the buffer to produce. Then you will again perform this operation and produce the items into the buffer. Produce the items into the buffer again. Again you have to consume them. So this is a process of we call it as a producer consumer problem. And what is the use of this producer consumer problem is where you have to you can implement this producer consumer problem using the semaphores. Okay, where you can use wait and signal functions. So wait and signal functions can also be implemented, where we call it as a bounded buffer problem. So this is a basic information of producer consumer problem that can be implemented for a classic problems of synchronization, which we are going to see in the next class. Classic problems of synchronization. So what are the classic problems of synchronization is? One is a bounded buffer problem. Then dining philosopher's problem. Then you have is a reader's writer's problem. So all these 3 classic problems of synchronization will be implemented with the help of this producer consumer problem, whereas this code gives you very important for how the producer can produce the item and consumer can consume the items, for which you need data to be shared. So the data that should be shared is what is the size of the buffer size and the structure where you can produce the items, and the 2 variables in and out, which are initially initialized to 0. Therefore it increments to the next buffer size where that items can be produced into that location, and from where the consumer can consume those process from the same. So here this is a basic data that you require, for which again we are taking 2 types of buffers. One is a bounded buffer and unbounded buffer. For all the classic problems of synchronization, we will be taking a limited access, so we will go with the bounded buffers. That's why it's named as a bounded buffer problem. Even in the producer consumer problem also, we will go with the bounded buffer where there's a limit of buffer size. Okay, hope you all understood. Thank you all.